In this video, we're going to do an inequality that has an absolute value on both sides of the inequality symbol. So what we're going to do first is we are going to rearrange this. I'm going to rearrange it so that all of my inequalities are on one side. So I'm going to subtract the 3 times absolute value of y minus 2. After doing that, I will wind up with this inequality, which makes it a little bit easier because I'm trying to figure out when would this expression be greater than 0, or in other words, when is it positive? Well, to do that, we want to look at each of these absolute value operators here, and we're going to make a piecewise function. I'm going to keep this as short as I can. So if you need more explanation, we can get into that. But we want to look at each of these and figure out when is that going to be 0. Well, y minus 1 would be 0 when the y value is 1. This one, y minus 2 times 3, would be equal to 0 when the y value is 2. So that's going to help me set up some intervals. This behaves differently for different values. At 1 is when it's actually 0. So anything less than 1 is going to give me the negative version of the y minus 1 expression. And so we're going to have to apply those intervals to the appropriate expression in there. So first interval will be we'll use interval notation here, from negative infinity, as low as it goes, up to 1, because something's going to happen at the number 1. And then we're going to go from 1 to 2, because things will be different there. And then we're going to go from 2 to positive infinity. So let's assess. We have numbers lower than 1 here. And if I plug it into this one, I'm going to be negative. And so I'm going to negate y minus 1. So if I distribute that, I would get a negative y and a plus 1. Then I'm going to write minus 3. Then this expression, y minus 2. If I use a number less than 1, I will get a value that is negative. And so I'm going to use the negative version of y minus 2. I'm going to put parentheses or brackets here, but I'm going to negate this. So now it says negative y and positive 2. So for this interval, this is how this behaves, from negative infinity to 1. Now we're going to look at the second interval. And if I plug in a number greater than 1 but less than 2, like 1.5, I would get a positive here. So I'm just going to use the regular expression y minus 1. Then I'm going to plug in a number between 1 and 2 here. Anything between 1 and 2 minus 2 would give me a negative result. So I will again distribute that negative. So I'm going to get negative y plus 2 again here. And then on my third one, I'm using numbers greater than 2 all the way up to infinity. So any number that I plug in from that interval would make this a positive, which means I can just write it as it was. And then for the second set here, anything greater than 2 would still leave me with a positive. So I'm just going to put y minus 2 this time. We can simplify this expression. It'll just make it a lot easier to interpret. So if I distribute it here, I'm getting a positive 3y, which is going to go along with that negative y, and that's going to give me 2y. And then I'd also have a negative 6 when I distribute here, and then a plus 1, so a minus 5. So this is the simplification of how this is going to behave from the interval negative infinity to 1. So I'll note that as well. From negative infinity to 1, that's what it looks like. 2y minus 5, the linear equation there. Then the second one, same thing. We're going to simplify. Positive 3y plus 1 more, that's a 4y. And then a negative 6 minus 1, it's a -7. And we're going to use that from the interval 1 to 2. And then in this last one, you get -3y plus a 1y gives you -2y. And then +6 minus 1 is a +5. And that's over the interval 2 to infinity. So now we're going to see when these expressions actually equal 0 and see if it applies within that interval. If it doesn't, we're not interested, because even though this will cross the x-axis, it won't happen within the window that we're looking at, so we would not worry about it. The first one, if I did 2y minus 5 equals 0, and I solved that, I would get y is 5 halves. 5 halves is 2.5. It's greater than 1. It doesn't fit in this interval, so I am not going to look at that. That's not going to help me. Then we'll do this one. If I solved this equation, 4y minus 7 equals 0. If I solve that, I would get y equals 7/4. Okay, 7/4 is 1.75, and it does lie in that interval. So we have 1 point here where we know something's going to happen in the right interval. And then if I do the third one, -2y plus 5 equals 0. I solve that. I will get a -5 over -2, which is once again 5 halves. And that's 2.5. And that one does fit in that interval. So we have two different areas where things are going to get interesting for us. So let's go to a number line and just kind of think about what numbers we're looking at. The first one was the fraction 7/4, which I'll write as 1.75, and the second one was 2.5. And these are the moments where things are going to change for us. So we want to see, are these solutions the numbers from -infinity to 1.75? Are the solutions here from 1.75 to 2.5? And are there solutions up here from 2.5 and on? What we can do is plug in a number from each of those regions, and I would keep numbers as simple as you could. Just plug it into the real one here and see if it makes sense. So I'm going to give myself some space here, covering up my extra work here. Let's just plug in something from this area. That would be like 0. Let's try 0. 0 minus 1 is -1, but when we absolute value that, we would get a 1. And then 0 minus 2 is -2. When we absolute value that, we get a 2, which is times a 3. It's a 6. So is 1 greater than 6? No, which means these numbers are not solutions. Let's try something between 1.75 and 2.5. Let's try the number 2. If I plug in a 2 minus 1 is 1. Absolute value of that is 1. Greater than 2 minus 2 is 0. 0 times 3 is 0. 1 is greater than 0. Yes, it is, which means this region so far has solutions in it. Let's see about 2.5 or above 2.5. Let's pick the number 3. That's an integer above. Let's plug in 3. 3 minus 1 is 2. 2 absolute valued is 2. 3 minus 2 is 1. Absolute value of that is 1 times a 3 would be 3. Is 2 greater than 3? No, it is not. So this one didn't work. This one didn't work. So this is where our solutions are. You can write this in different ways, but the y value would be lower than 2.5, and it'd be greater than 1.75. That would be, as an inequality, interval notation, 1.75 to 2.5, not inclusive, because we didn't have the equal to there for any of those. And if we go to the graph on Desmos, we will confirm that this is where this absolute value graph is greater than 0, as I had first set up my inequality. This right here is your 1.75 and your 2.5. So thank you, and I hope that helped.